So I am going to clump slides 10, 11, and 12 together. So first we're going to look at this slide. It says not all mutations are harmful. Remember, some mutations are detrimental, which means they are harmful. Some mutations can be beneficial, right? And that can lead to surviving and undergoing evolution. And the third one is it may not make any difference at all, right? And so these first two things we're going to look at is does it really make any difference, right? We're going to look at some detrimental ones at the end, but these two are examples of things that it doesn't really make much of a difference, right? And so we have grapes on slide 11, and grapes in this case some are red skinned, some are not red skinned, they're green, and they're missing um, melanin in their skins, right? And so does it really make any difference though? I mean, is it harming the plant? I don't know. Is it giving it a benefit? I don't know. Right? So there are some that they're not clearly harmful or helpful at all. The only thing that might make a difference is what if one of them was sweeter than the other? And so it's supposed to be red. Let's say that the green ones are sweeter and the birds eat them more than the red ones, right? Well, if the green get eaten, they're not gonna be able to reproduce, right? Their seeds aren't going to be put into the genetic pool, so to speak. The red ones would be, but I don't know if they have higher levels of sugar or not. So probably doesn't make much of a difference. Next slide is a multicolored cat. This is not necessarily a cat that this is what you get when you cross a black cat with an orange cat. It's a cat that has a genetic mutation, and so the cat looks a little bit funky. It's pretty cool. Would it be beneficial? I don't know. Would it be detrimental? I don't know. Have no idea if this organism would benefit from being this color or not. Next is slides 13. And slide 13 just quickly mentions that not all mutations are harmful. Okay. And so, an example of this, and when we say not harmful, we mean not harmful to the organism, right? And so, if you think about a fun little sickness like strep throat, and it's not fun, that was sarcasm, right? Your throat is really sore, you feel really, really sick. And if it doesn't get taken care of, you can have permanent heart damage, right? If you have strep throat. And so strep throat is caused by a bacteria. Now, most bacteria can be killed by antibiotics, right? That antibiotics have saved millions and millions and millions, probably hundreds of millions of lives since it was discovered. And so, one of the things about bacteria is that they reproduce really, really quickly. And because they reproduce really quickly, they also can mutate very quickly. And so, what has happened since bacteria, not bacteria, since antibiotics have been brought into the system, is there are now bacteria that are so strong, right? They are antibiotic resistant, which means that the antibiotics don't kill them. Now, that's not a good thing for us, but that's a really good thing for the bacteria, right? So that is actually antibiotic resistance is actually a really good thing for the bacteria. So I'm going to stop here, and we're going to go on next in the next clip to inherited genetic disorders in specifically in humans.